Good day, everyone, and welcome to Physics and Mathematics Lovers. Before us here today is a topic on physics. The topic says dimension analysis of some physical quantities. All right. In my previous video, I gave explanation of fundamental and derived quantities. Today, we want to know their dimension. So when we talk about dimension of physical quantities, we're actually looking at how that quantities are related to the quantity length, mass, and time. So in physics, dimension described the way all these physical quantities, more or less derived quantities, how they are related to length, mass, and time. So in physics, the dimension of length is denoted as L, capital letter L, while the dimension of mass is denoted by capital letter M. So that of time is denoted by capital letter T. So now, if I want to give the analysis of some other quantities, we want to look at how they are related to L, M, T. So now the first one we want to look at now, let's start from the lowest quantity. Let's say, for example, we have area. Area is a derived quantity. So it is derived from what? Length times breadth. Times what? Breadth. So now, the dimension of length and breadth is written as what? L. L. Because breadth is talking about the distance between 2 points, while length is also distance between 2 points. So if the dimension of this is this now, so at the end of the day, if you want to know the dimension of area, it will give us what? L square, which is what? L times L, equal to what? L square. So that is the dimension of what? Area. So the next one we are going to look at, this one is number one. Number two, we look at volume. Volume. Volume is denoted as what? Length times breadth times height. So this length is also a distance. Breadth is also a distance. It is also a distance between 2 points. So all of them, the dimension of each of them is what? Length times length times length. So in this is L times L. All of them are of the same base. At the end of the day, we have L cubed. So the dimension of volume, which is V, is equal to L cubed, meaning L raised to power 3. So let's look at another quantity like speed. If we have speed is a derived quantity, and it is derived from what? Distance over time. So in other words, distance is also talking about length, difference between 2 points. So we can also say that length over what? Time. And we already know the dimension of length as what? L. Then that of T, which is time, we call it what? T. It is represented by what? T. So the dimension of speed now will now be equal to L times what? 1 over T. So in this is, when you see 1 over any number, it becomes what? L times T raised to power minus 1. So the dimension of speed now is equal to L T minus 1. That is number 3. Now let's look at another quantity. Let's say velocity. Velocity, number 4. Velocity is defined as displacement over time. Displacement over time. So if you want to know the dimension, this displacement here is a distance measured in a specific direction. So meaning that you are also talking about length. We can also say length all over time. So L all over T. So the dimension of time is what denoted as t. So at the end of the day, we are still going to have velocity as equal to what? L t raised to power minus 1. So this is dimension of velocity. So which other one can we look at? Okay, let's look at acceleration. Acceleration. So let's look at acceleration as our number 5. So number 5, we have acceleration. What is the formula for deriving acceleration? So number 5, we have acceleration. Acceleration is certain as what? Change in velocity all over change of all over what time, which is velocity over time. So in this case, we have already deduced or derived the dimension of velocity. What we just need to do, just put it here. This is our velocity here. Bring it. So at the end of the day, your acceleration A will be equal to, we have L, remember, L t raised to power minus 1 all over t. So at the end of the day, we still have another t here. So we're going to make it in a linear form. It will now give us equal to L t minus 1, then times another t raised to power minus 1. So what we will do now is this one, the t and t are the same. So bring it on, bring L down, L t, then minus 1 minus 1. We add the powers according to the law of indices. The base, they are the same. So you add their powers, it becomes minus 2. So this is the dimension of acceleration. So the last one I want to give here is force. So force is equal to mass of that body times the linear acceleration. Times acceleration. So let's take it up here. So mass times acceleration, meaning that we have already known the dimension of mass as what? Capital letter M. And we just calculated for acceleration. We just discovered that. So now at the end of the day, you are going to have your force F equal to what? Mass, which is capital letter M, is denoted according to what we said before. Then times what is our acceleration here, which is what? LT square. We have LT square. So that is what we do. At the end of the day, your F will be equal to what? MLT square. This is the dimension of force. So we have other ones. Now what I wanted to do now, you go and look for the dimension of density. Density. Write it on the comment section. What is the dimension of density? So if you find this class very interesting, why don't you share this video? And do not forget to subscribe to our YouTube channel, Physics and Mathematics Lovers. God bless you. Bye.